Welcome to topic 5. We're going to do area and perimeters of quadrilaterals. Let's go back to unit 2 when we first did triangles, and we know the area of a triangle is 1/2 base times height. We've done this extensively many times. The height must be perpendicular to the base. That's the key. And if we want to do perimeter, we just have to add up the 3 sides. So this one is pretty easy. The height is 6, the base is 7, so my area is 1/2 times 7 the base times 6 the height. So this area is equal to 21 square units. And then we have to do the perimeter. We have to figure out what the sides are. Well, we know the bottom side is 7. It is isosceles, so we should be able to use the Pythagorean theorem to find the missing sides. Well, I'm only going to draw half the triangle. The height is still 6, but the bottom side is 3.5, and I know 3.5 squared plus 6 squared is going to equal that side C squared. This is side C. So C squared is 48.25, or C is about 6.9. So this side is 6.9, this side is 6.9. And my perimeter is adding up to 3 sides, 7 plus 6.9 plus 6.9. So my total perimeter is equal to 20.8 units, whatever the units are. And area of a rectangle, which we've probably done in this class earlier. Area of a rectangle, everyone knows length times width, or base times height. Because it's a rectangle, the height is perpendicular to the base. And really, if you look at this, we draw the diagonal at a rectangle. It's really 2 triangles, 2 right triangles. So the area of a rectangle is just area of 2 triangles. So that's where we get 2 times 1/2 base times height, and we get base times height. And the perimeter is adding up the 4 sides, which is I have 2 bases plus 2 heights, or 2 times the base plus the height. Going to my problem. My base is 9, my height is 3, so my area is equal to 9 times 3. So my area is equal to 27 square units. And my perimeter is equal to 2 times 9 plus 3. So my perimeter is 12 times 2, which is 24 units. So something else we've probably done in the past, the area of a square is just 1 times the sum of another side. It's base times height. It's a rectangle. It's base times height. But each side is all equal in length, so it's just area is side squared. And perimeter is just adding up all 4 sides. So 4 times each side. So for this problem, my area is going to be 8 squared. So this area is 64 square units. And my perimeter is 4 times one of the sides, and my perimeter is 32 units. I would think everything on this front page you've done at some point or another in your life, whether it be middle school or even this year. A parallelogram is just really kind of like a slanted rectangle, where the angles aren't right angles, but area is still base times height, but this time height must be perpendicular to the base, as it is in this drawing here. As you can see, this height is here. This is the height. The slanted side is not the height. It's this perpendicular side. Let's see how they come up with base times height. So I kind of redrew the parallelogram above it, and I even drew the height, the altitude here, and you can see maybe this little pink shaded area, I'm going to kind of move over to this side. So you see when I move that little pink shaded area to the other side of the parallelogram, and it's over here, I kind of have this whole new parallelogram that I'm going to shade in purple, the original parallelogram plus this new part here. And then you kind of see that this purple side is just really base times height in purple, which is exactly the same as a rectangle. So the area of a parallelogram and rectangle are very much the same. Perimeter, I just got to add up the four sides, and if I just don't know the other sides, I might have to use the Pythagorean theorem or distance formula, whatever you want to call it, to figure out the non-perpendicular sides. So for this example, my area is base times height. My base is 7.5. My height is 4, so the area is 30. My perimeter, it's kind of like a rectangle. It's 2 times, well, the bottom side is 7.5. The other side is 5. And there's 2 of them, one on top, one on bottom, so 12.5 times 2. My perimeter is 25 units. So the area of trapezoid is a little bit different. It's similar. It's kind of base times height, but it's a half times the height times the sum of the two bases. Again, the height must be perpendicular to the bases, and h is the height. B sub 1 is one base, either the short base or the long base, and B2 is the other base. And if you look carefully, this here is called the mid-segment that we studied the other day when we did trapezoids. So, pick a different color. Area is really just the mid-segment times the height. Our area is 1/2 B1 plus B2, because that was what the mid-segment is equal to, just the average of the two bases, or half the sum of the two bases times the height h. So we have to figure out, so I'm really going to just use this formula here, and when I want to do the perimeter, I just add up all four sides. Okay. So to do area, I need the bases and the height. My base 1 is equal to 3. My base 2 is equal to 7 if I count the squares on the bottom. My height, starts as h, is equal to 4. So my area is 1/2 times the height of 4 times the sum of the two bases. And my area is half of 4 is 2 times 10 is 20 square units. Now I have to figure out perimeter. So when I do perimeter, I have to figure out, I don't know what xy is. I don't know what dw is, those slanted sides. So I'm going to use my Pythagorean theorem. I'm going to draw a triangle. So you can see I drew my little triangles based on what I have for these little triangles over here to figure out xy. The bottom side is 1. The height is 4. I have 1 squared plus 4 squared is c squared. I got c was about 4.1. And then over here, I have a height of 4, and this side is 3. And to figure out zy, I did 3 squared plus 4 squared equals c squared. And I think Jasmine will be very happy to know that c is equal to 5, since she writes it on the board all the time. And when I want to do the perimeter, I'm just going to have the fourth side. So I have base 1 is 3, base 2 is 7, the ZW side is 5, and the XY side is 4.1. So my perimeter is 19.1 for this whole trapezoid. And finally, we have a kite and a rhombus, and they have the same characteristics that the diagonals are perpendicular to each other. So the area for a kite or a rhombus, you could work for a square if you wanted to figure out the diagonal of the square, but that's just more work, is the area is equal to 1/2 times the product of the two diagonals, and the perimeter is just adding up the four sides. Again, you might have to use the Pythagorean theorem. So over here, on this first kite, I know my first diagonal, left to right, is 8. My second diagonal, up and down, is equal to 12. So my area is 1/2 times 8 times 12. So my area is equal to 48. Now I have to figure out the perimeter. I'm going to do the same thing I did before by drawing little triangles and using my Pythagorean theorem. So you can see I did a triangle that has one side 4, the other side 4. So these are the top two legs or sides of the kite, and I get 4 squared plus 4 squared, or square root of 32, which means This is 5.7, that's 5.7. And then I did the 4, 8 triangle, and I got 4 squared plus 8 squared equals c squared, which equals the square root of 80, which is 8.9. So my perimeter is, well, there's 2 of the same size on top, 5.7, plus 2 of the same on the bottom for the kite. I get my perimeter is equal to 29.2 units. Okay, I'm going to do the same thing with the rhombus here. All 4 sides are the same, but find the area, new diagonal. Diagonal number 1 is 6 plus 6 is 12. Diagonal number 2 is 3 plus 3 is 6. So my area is 1/2 times 12 times 6. So the area is equal to 36 square units. Now I have to figure out how long each side is. I can just multiply that by 4. So I'm going to set up my little triangle. I set up my little triangle. The legs on the right triangle are 3 and 6. So C is the square root of 45, about 6.7. So my perimeter is just 4 times 6.7 because all sides are the same. So my perimeter is 26.8 units, whatever the units are for this problem. So the area addition postulate says the area of a region is the sum of its non-overlapping parts. So when I find the area of this roof, I really see, right now there's 4 shapes here. Shape G, H, J, and K. But actually that's only half the roof because all 4 of those sides I just said are also on the back side of the roof. So right now I have G, H, and K are trapezoids, and J is a triangle, and that's really only half the total roof. So I'm going to use my area of my trapezoids for G, H, and K. I'll use my area of a triangle for J. I'll add them together and multiply by 2, and that should be my total area of the roof. So I did the 4 panels that I see here, and for G, H, K, and J, I did all the areas. The first 3 are trapezoids, the last one's a triangle. So my total area of the roof, which we see double adding all these numbers together. So the total area is that would be 31,774 square feet.